Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to study symmetry. And let's see what is symmetry. So symmetry in mathematics can refer to one of two types. That means we have two types of symmetry. What are they? The first type of symmetry is line symmetry. Okay, we will know that. What is line symmetry? And the next one is rotational symmetry. That means it comes from the word rotation, to rotate. The word rotate, that means rotational, turning up, side, down, and so on. So let us start with number one, line symmetry. And what is line symmetry? Line symmetry deals with reflection and mirror image of shapes or parts of shapes. That means if we stand among a mirror, we can see ourselves. That means this is reflection. And this reflection of us onto the mirror, that means it's line symmetry. You can see the same of your body on the mirror. So this is reflection. So it deals with reflection of shapes. So we have to know things before we're going to have examples on line symmetry. So each side of the line symmetry is a reflection of the other side. That means if we have a shape and we divided this shape into n parts, that means all parts has to be equal. The same length and the same angle. Let's see this shape. So I'm forming this shape. Let's call this shape is triangle, you see, this triangle. And we have divided this triangle into two shapes. You see here, according to the line symmetry, where the line symmetry is in red. You see, in red. This triangle, we want to find the line symmetry of this shape. So let's divide this and make the line symmetry here. So here, this shape has one line symmetry, you see, this part equal to this part. That means they are the same. And this part is the reflection of this part. So because of this, they say that each side of the line symmetry is a reflection of the other side. That means this line is the reflection of this. Okay, let's see and other ideas and other informations about line symmetry. So that means let's keep this one, you see, keep this part. If we have just kept this part, that means it's equal to this part, you see, the same part. This part equal to the previous part. That means we have just divided this into two parts because the possible line symmetry, we can find it here. Okay, lines of symmetry also can be thought of as a folding line too. But what do I mean by folding? Folding زي كأننا نطبق لنا ملاية نطبق ملاية أو طي. This is the meaning of folding. Joining part, that means we are going to join. You see, look here. If we have just formed this, we want to join this blue into this red side, and we have to join this line to this red line. That means we are folding this shape. And if we are folding a paper, we are folding a paper. If you are folding a paper, that means all sides has to be equal, and even those vertices. We are folding this side, and let's fold this also. So it could be folded like this. That means this shape is folding, and also it has a reflection. And then we call this line symmetry. Let's have examples here. The question is how many lines symmetry we can find in this shape. So what do we call this shape? This rectangle. How do we know this rectangle? Its two sides are equal. So this side equal to this side, this side equal to this side, and also those two sides are equal. So these lines mean those two sides are equal and those two sides are equal. Okay, this we call this rectangle. But how many line symmetry we have here? So that means we can fold this and divide it into shapes or into part, small parts. Let's divide this. So I can say this shape or this rectangle has only two line symmetry. But how? It is the first line symmetry, because if you fold this, so it will be the same. The upper one, the same as smallest one here, or in the bottom here. The bottom and the top are equal, see? And then also we can divide vertically like this from the middle of the shape. Also this part is equal to this part, and at the same time this is a mirror for this part. That means it's a reflection. From this we can say that we have two line symmetry in red and in yellow. So what about this shape? This shape, all sides are equal. That means it's square. And the square always have four lines symmetry. Four line symmetries. Let's check this. Say that all sides are equal. It has four because we can divide here. And also we can divide this part into two. And also we can divide this diagonally. And also we can divide like this. That means this side equal to this side. And also this side, the upper space of this green or above the green line is equal to this one also. And in a yellow, so this space also equal to this space. That means square always have four, or square always has four symmetries, four line symmetries. Let's see this shape. What do you call this? Kite. This kite, you see that those two sides are equal, and those two sides are equal. And then I can say that the question is how many line symmetry we can get from this. Think about it and compare your answer. It has only one, because we can just divide this into two parts. We have only one line. Let's see this one. So this is different from the previous one. This shape. How many line symmetry do we have? Think about it. I'm giving you a few seconds to solve this or to find the answer. How many line symmetry? Okay, if you said no line symmetry, no line symmetry, your answer is true. Let's see this one. So first of all, before this, we need to smile. Right now you have to smile. Yes, I'm talking to you. Please smile. Because once you smile, you feel better and it makes other people feel happy. Smile. And I have just brought you this smiley face. And I want you to tell me that how line symmetry do we have? Just say it. Okay, let's say this face. You can say that this is according to our face. Maybe someone come and say that, oh, it has 4 line symmetry, but the answer is not. 2 line symmetry, not. Okay, let's see. It only has 1 line symmetry. 1 line symmetry. And it is like this. Because when you divide this space into 2 parts, and I want to make this to be the conclusion of line symmetry. The line symmetry, that means you have to divide the shape into equal parts. That means the same space here has to be here. The same shape has to be here. And if you divide this space into 2 parts, you can find 2 eyes. 2 eyes. 2 eyes has been divided. 1 eye here, and the other one is here. And even the smiley mouse has been just divided into 2. So the other part is here, and the other part is here. That means it's line. It has only 1 line symmetry. 1 line symmetry. Okay, why if we said we can divide it like this? Someone can say that why if what will happen if we divide the line symmetry, or if we draw the line symmetry here? If you draw the line symmetry here, this is incorrect. Why? Do we have 2 eyes here? No, we don't have 2 eyes here. Do we have a smiley mouse here? No, we don't have a smiley here. That means it's not, because the same things here must be here. That means this is not. That means we are not going to draw our line symmetry like this. Our line symmetry has to be drawn like this, because we have 1 eye, 1 eye. A part of the mouse, smiley mouse, a part of the smiley mouse is here. That means we have 1 line symmetry for this shape. I mean the smiley face. Again, you have to smile. Smile. Okay, let's see the other part of the lesson. Rotational symmetry. What is rotational symmetry? Rotation. Rotation. زيها listen. Rotation. Let's see this triangle. But what is the kind of this triangle? This triangle is equilateral triangle because all sides are equal. And let's see the first question. How many line symmetry do we have? How many line symmetry do we have? Okay. I'm going to say that I have to divide first. If I draw a line symmetry here, this part equal to this part. And it can be fold or folding. Again, I can draw my line symmetry like this. Also, this part equal to this part. Also, I can draw line symmetry from here. This part equal to this part. That means how many line symmetry do we have? Let's count. 1, 2, 3. We have 3 line symmetry. Let's check if the answer is true. Yes, 3 lines symmetry. See the other question, rotational symmetry. Oh, rotational symmetry. Okay, that means the rotational symmetry is the order of the rotational symmetry. That means what are the orders of this shape? Okay, let's check this. What do you mean first by rotation? Rotation, that means we can rotate this side. If we rotate this shape like this here, so definitely it will be here. If we just rotate, see? Let's rotate this. Just imagine that we are rotating this shape. turning and changing the position. You see, this vertex will be here, and this vertex will come here, and this vertex will come here. The same position, and even no change with the line symmetries. You see, if we just have turned this position, that means it has 1, 2, 3. It has 3 rotational order, or this rotation is of order 3. Let's check the answer. Rotational symmetry of order 3. That is the order of this rotation. The 3. That's 1, 2, 3, because it had 3 vertex. 1, 2, 3 vertex. We change like this, so this will be here, and this part will be here, and this vertex will be here. Again, it is the end of the lesson. And please, if you have any question, please tell me and ask your question. Please feel free to ask me your question. So next lesson is going to be similarity. And the assignment will be uploaded on Edmodo. Thanks a lot for watching. See you next lesson.